NBS. Clear? Now, NBS is referred as N-bromosuccinimide. Okay, so this is a full form of N-bromo, NBS, N-bromosuccinimide. So, few points you have to remember in NBS. It is a brominating agent and also act as an oxidizing agent. First, we have seen the preparation of NBS, that is from succinic acid. When first succinic acid is heated, gives a succinic anhydride by sublimation reaction, by elimination of water molecule. Then this succinic anhydride react with the ammonia, gives succinimide. Now, which is then react with the NaOH and Br2 at 0 degrees centigrade, we get NBS, that is N-bromosuccinimide. Now, we have already discussed NBS as a brominating agent, NBS as an oxidizing agent. And NBS act as a brominating agent through the radical mechanism. So generally this NBS is used for the allylic bromination. Bromination at allylic position. We have already discussed allylic position and the vinylic position in the double bonded compounds. Okay, so bromination proceeds through a radical mechanism. This is very important question. Okay, so if we given cyclohexene, first when we treated with NBS in non-polar solvent like carbon tetrachloride, it gives brominated product, that is 3-bromocyclohexene, which is then react with the base morpholine. Morpholine is act as a base. So base will abstract the proton, shows the elimination reaction and forms the diene. Now this diene still contain a 2 allylic carbon. So if we add the NBS in this diene, what happened? Allylic bromination will take place, which is then treated with the morphine. Sorry, morpholine, not morphine, morpholine. Undergoes the elimination reaction and gives the benzene or triene. So to prepare the benzene from this cyclohexene, we have required 2 moles of NBS and 2 moles of morpholine. Okay. The next that we have discussed, NBS as an oxidizing agent. So whenever the primary alcohol get oxidized in presence of NBS, gives aldehyde, while secondary alcohol oxidized in presence of NBS gives ketone. And I have also asked in homework, why tertiary alcohol not oxidized? So if we have tertiary alcohol and if I add the NBS, there is no reaction will take place. What is the reason? What is the reason? Because this tertiary carbon do not contain the hydrogen atom. That's why tertiary alcohol do not oxidize. ओके यहाँ पे देखो 2 हाइड्रोजन है, यहाँ पे 1 हाइड्रोजन है, यहाँ पे इसका टर्शरी कार्बन पे एक भी हाइड्रोजन नहीं है. दैट मीन्स दिस टर्शरी अल्कोहल डू नॉट ऑक्सीडाइज इन प्रेजेंस ऑफ NBS. Okay, and why this tertiary alcohol not oxidized in presence of NBS? For that we have to understand the detailed mechanism of the oxidation. Okay, and that we will talk Later on, when we have required the mechanism, then we will discuss. Okay. So in this class, we are going to learn one more reagent, that is lithium aluminum hydride. Lithium aluminum hydride. Okay. So this is lithium aluminum hydride. So this is a aluminum attached with the 4 hydrogen atoms. That's why this aluminum become negative in charge. And this negative charge stabilized by the counter cation lithium plus. Okay. And this lithium aluminum hydride is good reducing agent. Good reducing agent. And it is a non-selective. It is a non-selective reducing agent. Later on, I will talk with you what is a selective reducing agent, what is non-selective reducing agent. So this lithium aluminum hydride generally delivered H minus. Clear? Because the electronegativity of aluminum is 1.6 and the hydrogen electronegativity is 2.1. So hydrogen atom here is more electronegative than this aluminum. So this lithium aluminum hydride generally delivered H minus. That means gives hydride, gives the hydride. And this hydride act as a nucleophile. Act as a nucleophile. Okay. Understand the properties of this lithium aluminum hydride. It is act as a reducing agent. It is a non-selective, means it reduces the most of the functional groups. And it gives the hydride ion, not H plus. It gives the hydride ion. Why it gives the hydride ion? Why it gives the hydride ion? Because of the electronegativity differences between the aluminum and the hydrogen atom. Hydrogen is more electronegative than the aluminum. How we can prepare this lithium aluminum hydride? So now we are going to discuss the preparation of lithium aluminum hydride. That is a commercially available reagent, and generally it is available in THF solvent. It is available in THF solvent. Clear? So first we are going to learn the preparation of lithium aluminum hydride. So lithium aluminum hydride is prepared by gradual addition of anhydrous AlCl3 in the paste of lithium hydride, and which is prepared in ether solvent. So lithium hydride, we already prepared the paste in ether solvent, and we are gradually added this aluminum chloride. The product obtained here is lithium aluminum hydride and lithium chloride. So lithium chloride here is a byproduct. So if I balance the equation here, 4 hydrogen. So here I have 4. I have to put 4. Put 4 here. Okay. So okay, now I have to put here 3. It gives the lithium chloride, not okay. So here only lithium chloride, LiCl. And this reaction generally carry out in inert solvent like ether. Now this lithium chloride is precipitated out by filtration. So this lithium chloride is generally removed by filtration because its precipitate get fall out. Then how we can get this lithium aluminum hydride? Now this filtrate is evaporated. So first we have removed the precipitate of lithium chloride. In the filter we have lithium aluminum hydride. Then this filter is evaporated in absence of air. In absence of air and carbon dioxide. So generally evaporation generally takes place in inert gases like nitrogen, argon. The whole process is carried out in inert atmosphere. And what we get, the solid lithium aluminum hydride. This lithium aluminum hydride is a gray white solid. Appearance of this lithium aluminum hydride is gray white solid. Gray white solid. And which is rapidly hydrolyzed by water by evolution of hydrogen gas. So when this lithium aluminum hydride react with the water molecule, it eliminates H2 gas. And this lithium aluminum hydride is decomposes in presence of water. Okay, so this is the preparation of lithium aluminum hydride. So we have to prepare the paste of lithium hydride in ether solvent. Then we are going to gradually addition of aluminum chloride. The lithium chloride get precipitated out, which is removed by filtration. Now in the filter, the lithium aluminum hydride is remain. Now we have to evaporate this filter, but the evaporation is carried out in presence of nitrogen or some argon atmosphere. So lithium aluminum hydride generally react with the water, even moisture, by evolution of hydrogen gas. So it is a moisture sensitive compound and it is a pyrophoric in nature. It catches the fire in presence of air. This lithium aluminum hydride is pyrophoric in nature. It catches the fire when it is exposed to air. So care should be taken while handling this lithium aluminum hydride. Moisture sensitive as well as it is air sensitive. And generally this lithium aluminum hydride, it is commercially available and available in THF solvent. So solid lithium aluminum hydride we cannot directly use in the reaction, but we can use the solution of lithium aluminum hydride prepared in THF. Okay, did you understood the preparation of lithium aluminum hydride? So special care should be taken while handling this lithium aluminum hydride. It is a pyrophoric in nature. You cannot keep the lithium aluminum hydride open in the air. It can immediately catch the fire because it is a pyrophoric in nature. So that's why this lithium aluminum hydride commercially available in form of solution prepared in THF. The solution is also pyrophoric in nature. Catch the fire immediately. It is the moisture sensitive compound. So generally the lithium aluminum hydride is operate in inert atmosphere, argon atmosphere. Clear? Is there any doubt? Is there any doubt? Did you understand clearly? Yes or no? So next we are going to learn the properties, the uses of this very important reducing agent, lithium aluminum hydride. So lithium aluminum hydride, if I have a functional group, and this functional group is reduced in presence of lithium aluminum hydride to alcohol. This is the concept. So most of the functional group converted into the alcohol in presence of lithium aluminum hydride. It is a powerful reducing agent. Suppose I have aldehyde, ketone, acid, ester, epoxide. So all these functional groups all these functional groups when treated with lithium aluminum hydride, because it is a non-selective, gives the alcohol. This is the concept of this reducing agent. Oh, I hope so it is clear. I hope so it is clear. If we have nitro group and nitrile group, both can be reduced in presence of lithium aluminum hydride to amine. So here we have R, CH2 and H2. Clear? are CH2 and H2. In some cases, this nitrile group can be reduced to aldehyde. Can be reduced to aldehyde. Later on, we will discuss when we get the primary amine and when we get the aldehyde. Clear? The next is amide. Amide also can be reduced in presence of lithium aluminum hydride to primary amine. So once you understand the role of lithium aluminum hydride, the concept is clear for you. Okay. So these are the functional groups when reduced with the lithium aluminum hydride are converted into the alcohol. Nitro group converted into the amine. Nitrile group can be converted into the amine or aldehyde. Even the amide can be converted into the primary amine. Is it clear? Okay. But it not reduce the double bond. If I have simple ethylene, and if I add the lithium aluminum hydride, no reaction will take place. That means lithium aluminum hydride is not reduced the olefinic double bond or ethylenic double bond. Is it clear? But there is an exception. And frequently ask the question about lithium aluminum hydride from this exception. Suppose I have a double bond and here I have attached some group. So this is my double bond. Here I have CH, here I have CH, and here I have some functional group timing. Let me assume the aldehyde. And this carbon is now beta and this alpha and this carbon is beta now. So suppose at beta carbon, if I have a benzene ring or phenyl ring, try to understand the architectural pattern of this molecule. So we have olefinic double bond. At one carbon we have aldehyde, that is alpha. Now on the beta carbon we have phenyl ring. Now if I add the lithium aluminum hydride, now it will reduce not only this functional group but also reduce this double bond. So first this aldehyde will reduce, then second this double bond will reduce. So generally double bond will not reduced in presence of lithium aluminum hydride, but at the beta carbon, in case of alpha beta unsaturated compound, alpha beta unsaturated carbonyl compound, if at the beta carbon, if phenyl ring is present, then the double bond is also reduced. This is a very important point. So, so generally, this lithium aluminum hydride not reduced the olefinic double bond. But it's very important. Phenyl ring or phenyl group. Let me write phenyl group. If phenyl group is attached at beta carbon of, this is referred as alpha beta unsaturated compound. So now it will reduce the double bond. Getting my point? Getting my point? Generally, lithium aluminum hydride is not reduce the double bond until a phenyl group is present in the beta carbon of alpha beta unsaturated compound. Then it reduces the double bond also. Then getting my point? Yes or no? Getting my point? So generally it will not reduce the double bond. But whenever at the beta carbon of alpha beta unsaturated compound, phenyl ring is present, then it will reduce the double bond, not a phenyl ring. Keep remember, it will reduce the double bond. Of course, the first this in this case aldehyde will reduce, then the double bond. It not happen that double bond is reduced first, then the aldehyde. Of course, aldehyde will reduce first, then the double bond. Clear? Okay. So first we are going to discuss the reduction of carbonyl compound. Reduction of carbonyl compound. So first we are going to discuss reduction of carbonyl compound. Let's see the mechanism. So suppose we have aldehyde. If I add the lithium aluminum hydride, then second water workup, means we have to add the water in the reaction. What is my product? So this aldehyde group is reduced to alcohol. So this is our aldehyde, and this aldehyde is reduced to alcohol. Let's see what is the mechanism of this reaction. So we have lithium plus NaLH4 minus. Clear? Now what happened first? Suppose this is my aldehyde. The lone pair present on this oxygen. First, form a complex with this lithium plus. So first it formed the complex with this lithium. Now we have LH4 minus. As we know that this carbonyl carbon is electrophilic in nature. Now this LH4 minus delivered the H minus to this electrophilic center like this. And what it gives, H, and here we get O. Okay, and now it forms complex with this like this. Clear? When I add the water molecule in this reaction, this is known as a workup, water workup. Now this salt will quench and gives CH2 and now become OH. This is a OH. This is the product. So my question is, one molecule of lithium aluminum hydride reduce how many molecules of aldehyde? The question may be asked for 1 mark. One molecule of lithium aluminum hydride reduce how many molecules of aldehyde? How many hydride ions can give by lithium aluminum hydride? How many hydride molecules can give by lithium aluminum hydride? Answer fast in chat box. एक लिथियम एल्यूमिनियम हाइड्राइड कितने हाइड्राइड आयंस दे सकता है? जितने हाइड्राइड आयन दे सकता है उतने एल्डिहाइड मॉलिक्यूल को वो रिड्यूस करेगा. तो कितने हाइड्राइड आयन दे सकता है? कैन आई गिव द ऑप्शंस? यस और नो? जरूरत है यहाँ पे ऑप्शंस की. बहुत ही सिंपल क्वेश्चन मैंने पूछा है. लिथियम एल्यूमिनियम हाइड्राइड कितने हाइड्राइड आयन दे सकता है? एब्सोल्युटली राइट. सबको आंसर देना है, एक दो स्टूडेंट्स नहीं. और आंसर्स आर मोस्ट वेलकम. 4. Absolutely right. So one lithium aluminum hydride can reduce 4 molecules of aldehyde. Okay. So if we have aldehyde, and if we add lithium aluminum hydride, so 4 molecules of aldehyde reduced and form this intermediate complex are CH2O, which is then coordinate with aluminium and lithium. Now, which is then hydrolyzed or simple referred as a water workup. Gives four molecules of alcohol along with aluminum hydroxide and lithium hydroxide. Clear? So aldehyde is reduced to alcohol. But what we have to learn here, one lithium aluminum hydride molecule reduced how many molecules of aldehyde? Four molecules. Is that clear? Okay. Now you have to tell me the product of this reaction. If I react this molecule with the lithium aluminum hydride, now you tell me the product of this reaction. Of course, the four molecule of this will reduced by lithium aluminum hydride. Four molecules of DAS will reduced by lithium aluminum hydride. What is the name of this molecule that I want to know? Your answer is most welcome. Please answer in chat box. And give me a product. Benzyl alcohol is the name of product or starting material. So you can prepare for the examination in the lecture. Okay, once you know the concept, you can easily answer this kind of questions. Product is benzyl alcohol. Very good. So this aldehyde get reduced to alcohol. So this aldehyde is reduced to alcohol. So this carbon get reduced to CH2OH. Okay. Now you have to tell me why this reaction is called reduction. Why this carbon is called why this carbon is reduced to alcohol. So for that you have to find out the oxidation state of this carbon. Oxidation state of this carbon. And you have to find out the oxidation state of this carbon. Then we can able to tell whether this reaction is oxidation or reduction. Okay, so this is your homework. we can find out the oxidation state of this carbon and that carbon. So this overall reaction is reduction. But what about the carbon? Carbon get oxidized or reduced? Now I want to name of this product. Starting material. Product is benzyl alcohol. But what is the name of reactant molecule? Sam, three students must know it, the name of this reactant molecule. As I said earlier, benzaldehyde. They may give you the name of the molecule or may give the structure of the molecule. I'm talking about the examination. Examiner may give you the name of the reactant molecule or the structure of the molecule. Or maybe ask the name of the product or structure of the product. So the name of the reactant molecule is benzaldehyde. Okay. Let's say the next reaction and you have to tell me the product. The name of the reactant molecule, name of the product. So I always write the aldehyde in this way. When I reduce with the lithium aluminum hydride, what will be my product? Ethanol, that means number of carbons remain same. Here we have two carbons. So in the product also, there are two carbons. कॉमन मिस्टेक्स क्या होती है? ऑप्शन में आपको ये भी दिया गया होगा, ऑप्शन बी में आपको ये भी दिया गया होगा, फिर सी ऑप्शन आपको ये बना के देंगे, और डी ऑप्शन आपको ये बना के देंगे. And keep remember, we have written just lithium aluminum hydride, but after the completion of reaction, we have to add water in the reaction. This is referred as a workup, water workup. Okay, so please count the number of carbons in the reactant and the product. Number of the carbons remain the same in the reactant and the product. They will not change. So be careful while selecting your options. Okay, what is the name of the static material? Methanol. So this is a IUPAC name. What is the common name of this reactant? It's a methanol. Methanol is wrong. Carbon is referred as a methane or ethane. It's a very famous molecule. If I oxidize this molecule, which will form? Aldehyde is oxidized to which functional group? Okay. So when I oxidize the aldehyde, we get carboxylic acid. Now tell me the name of this molecule. This is acetic acid. So this one is acetaldehyde. This one is acetaldehyde. It's a ethanol, not a methanol. Because we have two carbons, 1 and 2. And the carbonyl carbon is referred as a number 1 carbon according to the IUPAC nomenclature. And what is the name of the product? What is the name of the product? I'm talking about this product. What is the name of this product? Is a ethanol. Can I call this is ethyl alcohol? Okay. Clear? Now let's see one more reaction. And we are going to compare these two molecules. In both case, if I add lithium aluminum hydride, then the workup. Find out the product. So this question will ask for 2 marks, not for 1 marks. So here we have two functional groups. One is olefinic double bond, another one is aldehyde. So here we have double bond, aldehyde, and also this aromatic ring. Which will reduce first and what will be the product of these two reactions? As we discussed earlier, the aldehyde will reduce to alcohol. But what about the double bond? So suppose I number this reaction as a first and this is second. Okay. You have to just tell me in the first reaction whether the double bond is reduced or not. No. In second reaction? Okay. So be careful in this type of reactions. So here double bond will not reduce. Only this aldehyde is reduced to alcohol. And make sure the number of carbons should be same in the both reactant and the product. So here we have 1, 2, 3 and 4. So here we have 1, 2, 3 and 4. ओके एग्जामिनर को पता है कि आप कहाँ पे गलती करोगे. वो आपको एक कार्बन कम करके प्रोडक्ट बना के देगा, एक कार्बन बढ़ा के प्रोडक्ट देगा. प्रोडक्ट में अल्कोहल ही होगा, लेकिन स्टूडेंट्स की जो कॉमन गलतियां होती है वही होती है. नंबर ऑफ कार्बन शुड बी रिमेन सेम. अगर एक कार्बन वाली कम प्रोडक्ट कर दोगे तो वो प्रोडक्ट आपकी गलत होगी, क्योंकि कार्बन कम नहीं होने चाहिए प्रोडक्ट में. ठीक है. Tell me this product is right or wrong. Right. So this is an exception. So whenever on beta carbon, if we have phenyl group, so lithium aluminum hydride can reduce this double bond, not aromatic ring. एक ऑप्शन में आपको एरोमेटिक रिंग को रिड्यूस करके देगा. सो बी केयरफुल. डबल बॉन्ड इज रिड्यूस्ड. Aldehyde reduced first. So undoubtedly this aldehyde converted into alcohol. The second that it reduces is a double bond. And this will not reduce by lithium aluminum hydride. For that we require the platinum ion hydrogen gas. Platinum and hydrogen gas. Is it clear? Here the double bond is not reduced. Only the aldehyde group is reduced to alcohol. Okay. So when aldehyde is reduced to alcohol, which alcohol we get? Primary, secondary or tertiary? This is a 1 mark question. सबसे पहले हमने वही डिस्कस किया था 1 mark क्वेश्चन. aldehyde is reduced to alcohol, but this alcohol is primary, secondary or tertiary? It gives the primary alcohol. प्राइमरी, सेकेंडरी, टर्शियरी अल्कोहल में डिफरेंस क्या होता है? इसको हम बोलते हैं प्राइमरी. व्हेन दिस कार्बन इज अटैच्ड विद second carbon or group. Let me take the example. Okay. So when this carbon attached to the only one carbon, referred as a primary. If this carbon attached to one more carbon, okay, so here this carbon attached to only one carbon, and the second molecule, this carbon attached to two more carbon. This is referred as a secondary alcohol. This is a primary alcohol. Now, if this alcohol in which this carbon attached to three carbon atoms, this is referred as a tertiary alcohol. ठीक है. कार्बन की वैलेंसी कितनी होती है? 6 या 7? 4. तो यहां पे हाइड्रोजन आ सकता है? नहीं ना. तो यहां से गलती से हाइड्रोजन मत लिखना. कार्बन नेवर पेंटावेलेंट. कार्बन कभी भी पेंटावेलेंट नहीं हो सकता है. सिर्फ मास स्पेक्ट्रोस्कोपी जब आप पढ़ोगे तब आप ये मॉलिक्यूल पढ़ोगे CH5+ जो हाईली एसिडिक होता है. ओके. सो कार्बन नेवर पेंटावेलेंट. ठीक है. तो ये टर्शरी अल्कोहल होता है. क्लियर? सो व्हेन aldehyde is reduced by lithium aluminum hydride gives प्राइमरी अल्कोहल. ये 1 mark का क्वेश्चन है. ओके. क्लियर? ओके. So today we are stop here. In the next class we will continue with our topic, that is lithium aluminum hydride. So in this class we have started our discussion on lithium aluminum hydride. First we have seen the preparation of lithium aluminum hydride. So lithium aluminum hydride generally prepared from lithium hydride and aluminum chloride. So first we have to prepare the paste of lithium hydride in ether. We have to use inert solvents here like ether, THF. Okay. And what we get, the lithium aluminum hydride along with the lithium chloride, which is first precipitate out, which is removed by the filtration. Now in the filter we have lithium aluminum hydride, which is obtained by the evaporation, but in inert atmosphere. Now what is the role of lithium aluminum hydride? It is a non-selective. So in the next class, I will discuss with you what is a non-selective. Okay. What means of non-selective? Why lithium aluminum hydride is considered as a non-selective reducing agent. So aldehyde, ketone, acid, ester, even epoxide, all are reduced to alcohol. Which alcohol? Primary, secondary, or tertiary? That may depends on the functional group. Never says the primary. So aldehyde can give primary, but ketone gives the secondary alcohol. Acid gives the primary. Ester gives the primary. Epoxide gives the primary. But this ketone gives the secondary alcohol. Keep remember. So don't worry, we will take the more examples in the ketone. But the acid also gives the primary, ester gives the primary, epoxide gives the primary, aldehyde gives the primary. But ketone gives secondary alcohol, not a primary. NO2 is reduced to amine. Nitrile can be reduced to amine even in aldehyde, depends on the condition that we will discuss later on. Amide also reduced to primary amine, but double bond is not reduced by lithium aluminum hydride. But whenever the double bond is at the beta carbon, if we have phenyl group, in particularly in alpha beta unsaturated compound, if the beta carbon directly attach with the phenyl ring, directly attach with the phenyl ring. So lithium aluminum hydride reduce a double bond, even the functional group. Then we have discussed one molecule of lithium aluminum hydride reduced four molecules of aldehyde. The mechanism that we have discussed. Then we have seen different examples that how this aldehyde is reduced to primary alcohol and what care should be taken while attending this type of questions. The number of carbons should be remain same in the reactor and in the product. The common mistake done by the students in the examination. They never count the number of carbons in the reactor and the product. As soon as they see the alcohol, they select the option. Okay. So any question? Any question from your side regarding the lithium aluminum hydride, even the N-bromosuccinimide? Any question from your side? Any confusion? Any doubt? No. Okay. Thank you very much. If you have, you can write me on my Google Classroom. Okay. Till then, thank you very much, all of you. See you in the next class. Have a pleasure learning of organic chemistry. Yes, yes, please. Sure, sure. I will upload it on my Google Classroom. Don't worry. Okay. Thank you. Any other query from your side? Thank you, all of you, to join online. Have a pleasant learning of organic chemistry. Thank you.